Welcome to Chapter 2. This is about sequence structures like lists, strings, dictionaries, and tuples. Let's start with the second problem. We're asked to accept a word as input from the user and then print the word back to the screen without vowels. So here's an example. If we run this program and say input the word as nectarine, this will be the output without vowels. Please pay attention to the case. So if we run this program and then enter the word as blueberry, see here that B should be uppercase. So going back to this program, word is the input from the user for every character in the word. If we lowercase the character and if it is not in the vowels A, E, I, O, U, then print the character. The end is just an empty string because we don't want a new line after printing every character. We have a blank print at the end is to print a new line. One variation you could be asked in this problem is to print just the vowels in the string. So you just have to remove this not condition to get the answer. Keep in mind that this final print statement is not required, but I've just kept it to make things look pretty on the terminal. In the way it works is you provide an element to be checked, and then you provide a sequence like a string or a list or a tuple or a dictionary. If it's a dictionary, it's going to check the keys. So that's how in works. It checks if the element is there in the collection that is provided. Let's now look at the third problem in the textbook. Similar to the second problem, we are asked to accept a word as input from the user. Now instead of printing the non-vowels, this time they've asked us to surround the vowels with brackets. To show you a demo, if the word is blueberry, you'll see that U, E and this E are surrounded by brackets. So that's the idea here. The explanation is pretty simple. You just use a if check and print with a bracket, or just print it without a bracket if it's a non-vowel. That's about it. Let's now look at the seventh problem. The user now has to enter a string. We are going to interpret that string as a list where each element is separated by a comma, like this. If the user was to enter 1, 2, 3, 4, then we will create a list out of it with 4 elements, 1, 2, 3 and 4. After that, we are asked to remove the first element and then print the rest. So we use comma as a separator. String has a method called split. Using that, we get a list. Pop of 0 will remove the first element and we print the rest. So let's see this in action. 1, 2, 3, 4, and we have 2, 3 and 4. That's about it as far as the seventh problem is concerned. Turning our attention to the ninth, we are given two tuples. The first one is 1, 2, the second one is 3, 4. We are asked to combine these two tuples into one, that is 1, 2, 3, 4. So tuples have a property that when you add them, it doesn't do an element-wise addition, but it actually concatenates them and creates a new tuple. So here's how you do it: A plus B, and that's our result. Now the 10th question asks us to sort a list. So here's a list 10, 1, 5, 6, 7. This is clearly in unsorted order. By calling list.sort, this original variable list, the elements get sorted in increasing order, and when you print them, you see the right answer. A variation of this question could be to ask you to sort the list in reverse order, that is in descending order. You'll have 10, 7, 6, 5 and 1. One way to accomplish this is to provide a parameter called reverse equal to true, and that will produce a desired result. Let's keep one thing in mind before moving to the 11th question. A list is mutable, that is, you can change elements of a list in place without having to create a new list. With this in mind, let's move to the 11th question. We are given a tuple and we are asked to sort the tuple. A few moments back I mentioned that a list is mutable. A tuple is not mutable, so you cannot assign another value to a particular index within a tuple. The only way for you to sort a tuple is to create a new tuple. So here we make use of a built-in function called sorted. It takes the tuple as argument. It creates a list, but since we are looking for a tuple, We create another tuple by providing the output of sorted. Remember, the output of the method sorted is a list. Tuple takes an iterable as an input as well. So it creates another tuple, and that's how we get the result. Here's the output. Similar to the previous question, you could be asked to sort in reverse order. Now you know how to get that done. Let's now look at the 12th question. We should write a program to reverse a 2D array of integers implemented as a nested list in the order of 0th element of every inner list. So this is my understanding of it. You basically rearrange a list so that based on the first element of every list, you sort the elements of the outer list. So you'll have 1, 2, 3, 4, 5, 6, 7 and then 9, 10, because 1 is the smallest element among the other first elements, 5 and 9. So once you have this in ascending order, then you go ahead and reverse the inner list. Here's the code for it. So eventually when you run the program again, this should be the final outcome. I'm using what's called an insertion sort here. Sorting is a way to organize the elements within a sequence. So let's see how this works. We have I running from 1 through length of array. So it's going to go from 1 to 0, 1, 2. The key is the first element, and then j will be initialized to I minus 1. And then we'll keep iterating this inner loop. So long as an element needs to be moved to the right, this inner while loop will keep running. If not, it will break control and reach the statement wherein you will place the key. We'll look at this algorithm in detail in later steps. Once the array is sorted, which is once it reaches this stage, that is just before running the reverse inner list comment, the next loop here reverses the individual lists and reassigns it back to the array. That's what we do to get the final output. Here's a much more Pythonic way of getting this done. Let's break this down. Sorted takes two parameters here. It takes a sequence, which is the list of lists as input. Then the function parameter called key allows you to provide a function to map each element of the inner list to a particular numerical value. Here we map it to the element at index 0. So now the first list will get mapped to 9, the next list will get mapped to 5, and the third list will get mapped to 1. Sorted returns a sequence in ascending order. So array will now be sorted in ascending order, and it will have 1, 2, 3, 4 followed by 5, 6, 7 and then 9, 10. We use list comprehension to create our new answer. So we have inner is going to refer to this the first time. Now when this list goes in as a parameter to reversed, it returns a reverse iterator. List accepts an iterator and expands it into a full-blown list. So we use list comprehension to create the list of lists. Here's the output. Here's a bonus question for you. Swap only the first and last elements of inner sequences. So in the first case, you'll swap 2 and 1, 3 and 1, 1 and 4. The first two elements here now have nothing to swap here. In the case of a tuple, again, swap 4 and 1, 5 and 8, 9 and 13. In the third input, swap H and O, W and D. Remember that in 2 of the 3, that is basically for a tuple and string, you cannot reassign to individual values because they are immutable. Alright, hope you've solved it. Here's a solution. If the length of the inner sequence is less than 2, you have nothing to do, so continue. If not, use slicing to get the smaller sequence. If you slice a list, you'll get a smaller list. Same holds true for a tuple and a string as well. You'll get a smaller tuple and a smaller string. All these sequences support the addition operation, which produces a larger sequence. They just append to one another. So here's the demo of running the program. For the first one, the output is as expected. Here it is for the case of a tuple. And for a string. Switching gears to part 2 of chapter 2, we've been asked to create a phone directory with the first entry as given and the given phone number. Here's how you do it as part of dictionary construction. You can directly provide the data here. If you have multiple data points, you can use a comma and then provide the next key and value pairs like K2 and V2, where they can be strings or any data type. We've been asked to collect 2 inputs from the user, the name and phone, and we're asked to create 2 entries out of them for each name phone pair. And finally, get user input to look up the phone number by name, provide the phone number or an error message to make it a bit more friendly. So the name, the first name, the phone number, here's the second name, here's the second phone number. Let's look up even. Here we get the phone number. If we enter a name where the phone number doesn't exist, we'll get this message. You can try it out yourself. Keep in mind that when we use the get call, it returns a default that we provide if the key is not found. Here the key is a name. If we use the bracket notation and if the entry is not found, for example, if we use phone is equal to phone directory square brackets name and that's it. If the name doesn't exist, it's going to raise an error. The 8th question is very similar. Instead of 2 entries, we've been asked to collect 3 entries. I'm not going to go over this. Here's the code. Let's look at the 9th question, where we are given a dictionary that maps a student name to their score, and we want to print this dictionary in ascending order of scores. So we'll have student 3, 5, 2, 4 and then 1. Here's how you get it done. There is a Python built-in called sorted. It takes an iterable. Scores is a dictionary and it's a sequence, so it can also be iterated upon. Then it takes a key, a function that takes a single argument as input and then returns a value based on which the original sequence is sorted. So when we run this, you'll have the expected output. Let's turn our attention to 11a. We're asked to implement bubble sort. There is a minor bug in the textbook. The inner loop goes all the way to n. That is not required. Let's understand the details of how this algorithm works. So here are the intermediate steps. Let's map the code to these intermediate steps. N refers to the length of the array. You iterate all the way from 0 through n minus 1. So I is going to carry those values. So for the first iteration, I is going to be 0. J is going to go all the way to end of the array. You compare an element at position j with the element at position j plus 1 and swap if the element at position j is greater than its neighbor. So the very first time this loop runs, 5 and 4 will swap positions. The next time 5 and 3 will swap positions and so on. And by the end of the iteration, that is the iteration in the inner loop, you will reach this result. 5 will go all the way down. One observation to make here is the maximum element of the given list is now at the last position after the first iteration. The next iteration, we again start from the beginning and swap elements as required and go all the way till the last but one position, because we don't have to compare against 5 at this point. So 4 will now move down all the way to the last but one position. You'll end up moving 3 in the next iteration after that. Then 2 will fall in place. And by the end of this algorithm, you'll have the sorted list. That's the reason why you don't need to go all the way to range of n for the inner loop. So we end up printing the result. Here's the output. You can try for yourself using a random array here, and it's going to produce the sorted output. This time around, we're going to implement insertion sort. Here's the algorithm for it. The way this works is, we have the given array, and as we iterate, we're going to assume a certain invariant to hold true. Let's see the details now. We're given the array 3, 2, 1, 4, 5. There are 2 loops. The very first time key equals element at position 1. The inner loop finds the right home for the element located at index I. When I is 1, it points to 2. J starts one position to the left of I and then keeps comparing the adjacent element to its right and shifts one position to the right, the element at location J if required. Sorry if it's a bit confusing, but let's look at the details. J starts at position 0 because it's I minus 1. It compares 3 and 2. Since 3 is greater than 2, 3 can now be written here. Why then this inner loop comes to an end? Because J becomes minus 1 after comparing 3 and 2. As a result, 2 will be stored here. Array of J plus 1 equals key, and key is equal to 2. Right? So that's how the first iteration comes to an end. A partially sorted array where till position I, numbers are in increasing order. The next time I becomes 2. So you have 1 to be the key, and we want to find the new home for this 1. If it is already in sorted order, well and good. If not, we'll keep shifting elements and finally overwrite the missing spot. So first thing that the inner loop does is it compares 3 and 1. 3 is greater, so 3 moves one step to the right. Then it compares 2 and 1. 2 is also greater than 1, so 2 moves one step to the right. Finally, this inner loop comes to an end because J will become minus 1 and array of J plus 1 equals 1, so you'll have 1 here, and this goes on. One subtle detail here is this construct or this condition should hold true for the inner loop to continue. If at any point this condition is not satisfied, it will break out of the inner loop. So that's what makes this program more efficient than bubble sort. So here it is, an action. Let's end this chapter with an exercise. Now that you have seen both insertion sort and bubble sort, find out which algorithm runs faster. Here are a couple of hints. In both files 11a and 11b, fix the array input. Both of them should carry the same input for you to compare the relative performance. Have a counter variable that's outside both these for loops. Say you can have a counter after this particular statement. And then increment the counter by 1 for every iteration of the innermost while loop. The algorithm that runs faster should have a smaller value for the counter variable.